evening, everyone. Today we'll be discussing how we can determine how quickly an object's position changes over time. In other words, we'll explore how to calculate velocity using the derivative of position over time. To start off, let's clarify a few key concepts. Position refers to the location of an object in space. Time, on the other hand, is the progression of events in a particular order. And velocity is how quickly an object's position changes with respect to time. Now, let's introduce the derivative of position. The derivative, denoted as delta p divided by delta t, represents the rate of change of an object's position over time. In simpler terms, it tells us how quickly the object's position is changing at any given moment. Now, calculating velocity. Calculating the velocity of an object involves using the derivative of the position function with respect to time. The derivative represents the rate of change of position, or how quickly the object's position is changing at any given moment. Now, to calculate velocity, we follow these steps. First, you define the position function, which expresses the position of the object as a function of time. 2, you take the derivative of the position function with respect to time. This step finds the rate of change of the position function, giving us the object's velocity. 3, interpret the derivative as the object's velocity. The resulting derivative function represents the object's velocity at any point in time. 4, evaluate the derivative at a specific time to find the object's velocity at that moment. Substitute the given time value into the derivative function. 5, pay attention to the units. Ensure that the units of the position function and time are compatible, so the resulting derivative has appropriate units of velocity, example meters per second, kilometers per hour. Now, to better understand this concept, let's consider a scenario. Imagine a car traveling on the road with multiple stop points. We will take the derivative of the car's position at each stop point to determine its velocity. Now, let's start with the first stop point. Here, we have a diagram of the car's position. By calculating the derivative of the car's position with respect to time at this point, we obtain the car's velocity at that precise instant. This velocity tells us how fast the car is moving at that moment. Now, moving on to the second stop point, we repeat the process. We present a diagram of the car's position, calculate the derivative, and interpret the result as the car's velocity at that instant. Again, we gain insight into the car's movement and how quickly it's traveling. Now we're going to go on to our third and final stop. Now let's consider the third and final stop. Similar to the previous examples, we analyze the car's position, calculate the derivative, and determine the car's velocity at that specific moment. These instantaneous velocity measurements provide valuable information about the car's motion.